Hey there, aspiring web developers. Have you ever wondered how large-scale applications manage to stay online, handle millions of users, and never seem to lose your data, even when things go wrong? Today, we're diving into a fundamental concept called data replication. In simple terms, it's the process of copying and maintaining identical copies of your data across multiple servers. This isn't just about making backups, it's about making your systems robust and efficient. The primary reasons we implement replication are to achieve high availability, meaning your application is always accessible to users, minimizing downtime, and to ensure scalability, allowing your system to gracefully handle an increasing number of users and data requests without performance degradation. Imagine trying to serve a global audience from a single database. Among the many strategies for data replication, one of the most common and foundational is called Master-Slave Replication. We'll spend our time today exploring its architecture, how it works, its significant benefits, and also its limitations. Let's begin our journey into building more resilient web applications. So, what exactly does the master-slave architecture look like, and how do these components interact? Well, at its core, you have a single designated master server. This server is the definitive source of truth and is responsible for handling all write operations. This means any data modifications, like inserting new user information or updating a product's price, must go through the master. It's the only place where changes originate. Complementing the master are one or more slave servers. These slaves are primarily dedicated to handling read operations. When a user requests data, like viewing a product catalog, these read queries are directed to the slaves. This offloads significant work from the master. Crucially, this setup creates a unidirectional flow of data. Changes made on the master are faithfully copied over to the slaves, but slaves do not write back to the master. This clear separation of duties and distinct data flow is fundamental to the stability and performance of master-slave replication, allowing for efficient resource allocation and simplified conflict management. Now let's get into the technical details. How does this replication process actually happen behind the scenes? Well, it all starts when a write operation occurs on your master server. The master doesn't just make the change. It meticulously records every single modification, whether it's an insert, update, or delete, into a special, immutable file called the binary log. Think of this as a detailed, ordered journal of every change to your database. This log contains all the necessary instructions for replication. Next, a slave server connects with the master and continuously requests these binary logs. The slave then meticulously applies those recorded changes to its own database. This ensures the slave's data stays perfectly in sync with the master's. By default, this entire process is asynchronous. This means the master doesn't wait for the slave to confirm processing before accepting new writes. This design choice is critical for keeping the master fast and highly responsive, preventing it from getting bogged down. However, it also introduces the possibility of a slight delay, or lag, between the master and its slaves. So why bother with setting up and maintaining master-slave replication? It offers some truly compelling advantages for your web applications. Firstly, you gain fantastic read scalability. Because your slaves are dedicated to handling read operations, you can distribute the incoming read load across multiple slave servers. Imagine a popular e-commerce site. Thousands of users browsing products simultaneously. By directing these read queries to several slaves, you can handle a much higher volume of traffic without overwhelming a single machine, dramatically improving performance. Secondly, it significantly boosts high availability. If your primary master server unexpectedly fails, one of your healthy slaves can be quickly promoted to become the new master, ensuring your application stays online with minimal downtime. This failover capability is crucial for mission-critical systems. Lastly, slaves can also serve as dedicated servers for other vital tasks without impacting your primary master's performance. For example, you can use a slave specifically for running complex reporting queries, or even as a live data backup server, allowing you to take snapshots without interrupting your main database. These benefits collectively make master-slave replication a powerful tool for building robust web services. While master-slave replication is powerful, it's essential to understand its limitations and challenges. It's not a silver bullet for every problem. Firstly, the biggest challenge is the white single point of failure. Since only the master handles all write operations, if that master server goes down, your application's ability to write new data grinds to a halt. New transactions become impossible until a new master is successfully promoted. Another critical consideration is replication lag. Because the replication process is asynchronous, slaves might be slightly behind the master. This means if a user writes data and immediately reads from a slave, they might temporarily see outdated information. This eventual consistency model needs careful management. Furthermore, managing failover, detecting a master failure, and promoting a slave can be quite complex. It often requires sophisticated monitoring and automated scripts, and ensuring your application seamlessly redirects writes is a non-trivial task. For scenarios requiring higher write availability or extreme horizontal scaling, you might explore more advanced alternatives. These include multi-master replication, where multiple servers can accept writes, or sharding, which distributes data horizontally. Understanding these helps you choose the right data architecture for your project's needs.